So now let's talk about more resonating structure. Now if we draw one more resonating structure, this is one more compound. Now if we draw the resonating structure, first this electron will shift here. Now it will form CH2 double bond, positive charge here and here. Now this again will shift in the same direction. Now it will again CH2 double bond, positive charge here and here, this type of bond. Now again we will shift in the same direction. Now here it is again positive charge and CH2. Again we will shift in this direction. We will get the same compound, CH2 plus. So if we see how many resonating structure here we have, 1, 2, 3 and 4. There are 4 resonating structure. If we see, first and fifth are identical, so we will not count the fifth structure. There are 4 resonating structure. Now if we try to draw the resonating hybrid, now for drawing the resonating hybrid, we know that first we will draw all the sigma bonds which are fixed in that structure. Okay, CH2. Okay, now we will draw by dotted line all the pi bond shifted. So wherever the charge came, we will put delta positive, delta positive, delta positive and delta positive. And we know the value of 4 delta positive is equals to 1. There is only one charge present. So that's how we will draw a various resonating structure. If we see one more compound, how many resonating structures it has? It will have 7 resonating structures. This positive charge will keep on rotating on each and every side, so it will have 7 resonating structure. So you should know how to draw the resonating structure and how many types of resonating structures are there, and you should also know about them. Okay, so we will see further their stabilities, which are more stable and which are less stable. So let's see one more type of resonance. Okay, like if you have a compound NH2 boron and hydrogen attached with that. So we know the boron has one empty orbital. Okay, it has one empty orbital, and ammonia has one lone pair. So we know that when this is a conjugation, we have already seen when a lone pair is adjacent to a vacant orbital, this is a conjugation. So it will donate lone pair to the empty p orbital of B. Empty p orbital of B. This is empty orbital, empty p orbital of B. So NH2 will donate its electron to the empty orbital of B. Now this is actually in this is the outer electron. This is central atom. This is central atom and this is outer atom. Okay, this is outer atom, this central atom and this is outer atom. So now if we see this central atom and outer atom, this outer atom is donating electron to the central atom. So now what type of structure you will be seeing? NH2 lone pair, boron, hydrogen and hydrogen, and it is donating its lone pair. So now we know it is also p pi, it is p pi bonding. It is again we say it is a pi bonding. Okay, how it is a pi bonding? It will be NH2 plus B, hydrogen and hydrogen. So here B will have negative charge, again it is sp2 hybridized. Okay, so it will be the structure of, if you see the structure, it will have NH2 boron, hydrogen and hydrogen, and it will have delta positive charge, delta negative charge. Okay, so this is a p pi bonding because it is a pi bonding. Okay, it is a pi bond. We know due to resonance pi bond takes place. Now this comes from filled p orbital and this is from empty p orbital. So the electron was in p orbital, here electron was in p orbital. So it is p pi bonding. Okay, so we call it as a delocalization. If we see again one more structure, Okay, again we know chlorine has a empty d orbital. Okay, so it has empty d orbital, empty d orbital. So this electron goes here. Okay, so if we see further, carbon is double bond with chlorine, and chlorine and chlorine, it has chlorine will have negative charge. Okay, so this chlorine accepted electron. Okay, so again this is called p pi d pi bonding. It is called p pi d pi bonding, and chlorine has negative, chlorine has empty d orbital. It has empty d orbital, and it is p orbital electron. The lone pair is in p orbital. So again it is called p pi d pi bonding. It is also called back bonding. It is also known as a back bonding. Back bonding means outer atom donating electron to the center. Okay, so it is called back bonding. Okay, so if we want to draw its canonical structure, is its structure Cl, Cl, Cl. This is delta negative, and delta negative. So these all bonds are here. Okay, so again we know 4 delta negative is equals to 1. The charge of 4 delta negative is equals to 1. Okay, now further if we proceed with the resonance, we have seen the back bonding where the outer atom donating electron to the central atom. Now if we talk about the stability of resonance, stability of resonating structure. Okay, so there are certain points we need to see the stability of resonating structure. First of all, we will see neutron compound. If we have two types of compound, if we have like compound HCO, OH, it is in resonance with HCO minus double bond O plus H. Okay, we see this is a resonance. So now it is a neutral compound, and it is not not neutral. Okay, it is not neutral compound. So if you see, neutral compound will be more stable than non-neutral compound. So if we see the stability A and B, so we know A will be more stable because it is neutral and it is not neutral. So if there is a comparison between neutral and non-neutral, we will give priority to neutral in stability, because we know the potential energy here is 0 and it has some potential energy. When it has some energy, the stability will be less, so it is more stable. Okay, now if we see further point, the resonating structure in which octet of each atom complete will be more stable. So if we have two type of structure, now again if we see further this example, HCO minus C plus OH, it is in resonance with HCO plus C minus OH. It is, if we again talk about A and B, okay, these both are resonating structure which either one we have broken the bond in above side, one we have broken the bond in below side. So we know it is both have charged. Okay, first of all we will check whether it has charge or not. When it has charge, then we will check about octet complete. Okay, now here if we see, the octet is not complete here, or octet is complete here. So we will be seeing that A is more stable, A is less stable than B, because here octet is complete. It has completed octet. Okay, now it don't have any complete octet. Now if we see further third, the resonating structure having more covalent bond will be more stable. If we compare between two structures, okay, here it has A and B, both have charge and both have same type of structure, but here covalent bond is more. So we will be saying B is more stable than A. The resonating structure having less form of charge will be more stable. Having less form of charge, okay, suppose we have two resonating structure 4. we have two resonating structure, and one have less charge and one has more charge, less charge. So we know the compound having less charge will be more stable. So less charge will be more stable. If we see further point, if two resonating structure have same number of covalent bond and forward charge, then negative charge on more resonating element and positive charge on the more electropositive element will be stable. Now if we see further example, HC plus O minus OH and HC minus O plus OH. Again, we just see this example. Okay, here we know octet is incomplete. So here what we are talking about, complete octet and incomplete octet. So complete octet will be more stable than incomplete octet. Okay, this is not the proper example of this. Okay, it is also incomplete octet, it is also incomplete octet. So we will not consider this example. Just see when there is a complete octet and incomplete octet, the complete octet will be more stable. Now if we see this example, if both have the same charge, but here more electropositive is oxygen and less electropositive is carbon. So if it is more electronegative, then the negative charge should be present on more electronegative and positive charge is present on less electronegative, and here it is opposite. That's why if we compare their stability A and B, A will be more stable than B. Further we will understand more these by doing some examples.